Hello everyone, welcome back again to my channel. Don't fail Ask Mikhail. Today we're going to cover how you find the domain algebraically. I have like 10 examples, 10 different functions that we need to find the domain of each one of these functions. All right, so let's start. Before we start the example, I want to explain something first. When you talk about domain, you're talking about input. Very much you're talking about the x value. So you have two things. You have the x, you have the y. The x is very much the numbers input. You can substitute for x. And y is the outcome. What do you get? So the input, this is called domain, and the outcome is called the range. All right? So that is the domain and range. So now, when we ask about the domain, we're asking for what possible values we can put for x so the outcome be real number. Real means no radical negative, or no, when you have a fraction, you cannot have 0 on the bottom. So we're looking for these two things. Which value when you get a radical are negative and 0 on the bottom. Let's see a couple examples. So please put in your mind that you cannot have negative under a radical. That's I, imaginary. And you cannot have 0 on the bottom because that is undefined. So let's see some examples. 1 over x. So x on the bottom cannot equal to 0. No good. So if we draw a number line, here is 0. And by the way, number line is going to help us a lot for the domain. So x can be anything left and right of 0, but cannot be equal to 0 itself. So the domain will equal from negative infinity to 0. We'll put parentheses because I'm not including the 0. Union 0 to infinity. Anything but 0. Over here, what at the bottom? I have to look for what value for x will make this entire thing 0. So I'm going to set this entire bottom. Here is the key. You set the bottom equal to 0 to solve for x that will make the bottom equal to 0. So I'm going to make the 3x, which is the denominator, plus 9, equal to 0. Subtract the 9, divide by 3. Then you get 3x equal to negative 9, divide by 3, x equals to negative 3. Such that if you substitute negative 3 for x, you're going to get negative 9 plus 9 equal to 0, which is make the function undefined. So now you want to say that the domain, if I draw a number line, here is negative 3, circle, you're not including it, anything right and left to negative 3. So that's negative infinity to negative 3, union negative 3 to infinity. So very much I'm saying anything, and because I have parentheses, no bracket, that means I'm excluding the negative 3. Next example, look at this. What we have here, we have the bottom of the quadratic, so we need to factor. We need to factor the x squared plus 7x plus 12. So I have x squared plus 7x plus 12 equal to 0. So you're looking for two numbers, x and x. You look up for two numbers, you multiply, give you 12, they add up to 7, which is exactly positive 4 and positive 3. That means x will be equal, opposite signs, either negative 4 or negative 3. That means if you put x is negative 4 here, negative 4 for x, you're going to get a 0, or negative 3, you're also going to get a 0. So if I put a number line, I have negative 4, negative 3, put a circle. I want to say that domain is everything but these two numbers. Domain is this, and this. So I have three different domains now. The first one is from negative infinity to negative 4, parentheses. The other one is negative 4 to negative 3, parentheses. Then negative 3 to infinity. And guess what? We just put in between the U for the word union. Now, for this one here, the next one, I'm looking for something, what x can be. So, what x can be to make the radical negative. To make the radical negative, meaning x, I need to have it positive. I need on the radical to be positive, not negative. So what I make the bottom, no bottom here, the entire radical greater than or equal to 0. Because this could be 0. Radical 0 equal to 0. So I make it greater than or equals to a 0. So, and here, the values that I'm going to get are the domain. Remember, the value that I get here, these are excluding from the domain. The domain, anything but the numbers. Again, this is very important, everyone. Here, when you have a fraction, the domain is any number except the values that I get for x. But here, when I solve for x, for the radical, the values that I get are the domain. The values are the domain. So, I'm going to subtract 8. Then 2x greater than or equal negative 8. Divide by 2. Then x is greater than or equal to negative 4. So the domain will be, if I put a number line, and I have negative 4 here, equal means I shade the circle and I shade to the right, greater than. So that will be bracket negative 4 to infinity, parentheses. And I put bracket. Now, example like this. Oops. Let's look at it. First of all, this is a cube root. What do you mean a cube root? Cube root that is okay to have a positive and okay to have negative. Cube root. Negative number multiplied by itself 3 times give you negative 8. So what is cube root of negative 8? That equal to negative 2. So that means it is okay to have a negative here. So it can be any number here. So the domain here is from negative infinity to infinity because I'm not excluding any number. I have no restrictions here. The restrictions for radical, like this one here, the restriction is I'm not allowed to have negative. But here I can have negative because it's a cube, but this is a square. Let's look at the next one. So, I'm going to make this greater than or equal to 0, x squared minus 9 greater than or equal to 0. That means x squared greater than or equal to positive 9. Now remember, when you take the square root, then x greater than, you have to put it as an absolute value. The x actually is greater than or equals to 3, positive or negative 3, such that x greater than or equal to the positive number, then x, listen, when you deal with the negative, I hope you remember this from the last lesson, you have to flip the sign. When you do inequality, you have to flip the sign when dealing with the negative. So now, the domain, negative 3, greater than or equal, you shade to the right, you shade to the left, and here less than or equal to negative 3. There will be negative infinity to negative 3, union 3 to positive infinity. All right? And actually the key here, the trick, is because we're doing absolute or we're doing inequality, we have to flip when we do the negative. So, how about this one? We have square root of x squared. So we're going to equal this to what? To the 0. I mean greater than or equal to 0. X squared plus x minus 12 greater than or equal to a 0. All right, so we have to factor two numbers. You multiply, give you negative 12. They add up to positive 1, which is positive 4 minus 3, greater than or equal to 0. Now, listen. X, for this one, the negative 1 is going to be flip the sign, meaning this x, when I move the 3, x is greater than or equal to 3. But x here, when I move the 4, is going to be negative 4. You have to flip the sign from greater to smaller, because x plus 4 equal to 3 to 0 minus the negative, always get the flip the sign. So this actually, if I do a number line, I have 3, negative 4, less than or equal, and here greater than or equal. Now, you gotta say, Mikhail, can I test a point like 0 here? If I put 0, what I'm gonna have? I'll have 0 plus 1 plus 0 minus 12 under the radical, which is radical negative 12. Negative is no good. You cannot have a negative under the radical. What if I try 1? X equal to 1. So, let me erase this. And the next time, now I'm going to do x equals to 1. 1. So, we're going to be radical. 1 squared is 1 plus 1 minus 12, which is equal radical negative 10. Also no good, because you have a negative under the radical. So the domain actually is, what did I do? The domain actually is this part, negative infinity to negative 4, bracket, union, bracket, 3 to infinity. All right, question number 8. Now I'm having a radical and the rational on the bottom. So I cannot make it equal to 0. Over here I made it equal to 0. I got no problem here. That's why here I had the equal sign. No problem, it can be 0. So if I put equal to 3 square minus 9, that is 9 minus 9 equals 0. No problem. But here, you cannot have equal to 0 because it's on the bottom, and 5 over 0 is undefined. It's no good. So now what we're going to do, we're going to make the bottom 2x minus 10. Same thing exactly. Greater than 0, but we used to do here, or equal, like equal. We're not going to do the equal because we cannot equal to 0. Then 2x greater than 10, then x is greater than 5. So, number line, 5, circle that is open, greater to the right, that will be 5 to infinity. Parentheses, and I cannot put parentheses, I cannot put bracket. It has to be parentheses because I'm not including the 5. If I put x equal to 5 here, 2 times 5, 10 minus 10, that gives you radical 0, which is 0, and the bottom is undefined. Now, how about this? So, I'm going to, same thing. I'm going to make x squared minus 10 minus 100 greater than 0. That means x squared greater than 100, which is absolute value of x when you take square root greater than what? 10. Exactly like this previous example. So, x is greater than, keep the sign as greater to the positive, and x, you flip the sign, you make sure you flip the sign to make it the negative 1, the negative 10. So, number line, I have negative 10 and 10 greater to the right, smaller to the left, and no equal. That will be negative infinity to negative 10. Union, put parentheses on both, 10 to negative infinity. I mean positive infinity, I apologize. Right? Last example, what I have here. So I have the radical is on the bottom. So I'm going to make the bottom greater than 0. So x squared plus x minus 72 greater than 0. No equal because I cannot have a 0 on the bottom. So factor two numbers. You multiply. Give you negative 72. They add up to 1, which is positive 9 and negative 8. Remember, when you split it, this move here, then x will be greater than 8, because greater than the positive. When you move it, x will be, you have to flip the sign, and less than the negative number. All right? So on number line, I have negative 9, I have 8, greater, mean to the right, less, mean to the left. So that's negative infinity to negative 9, union 8 to infinity. All right, let me have one more example. Make it number 11. I was not actually prepared for it, but I thought about it while I'm doing the lesson. Okay, this coterminal angle, I don't know why I have this one here. I don't even can get rid of it. That's okay. All right. So what if I have this square root of 8x squared minus 4/8x? Can you take a minute, try to do it on your own, pause the video, and try to do it by yourself? Now, after you pause the video, you want to see how I did it? Well, 8x squared minus 48x. That is not a fraction. So it can be a 0, radical 0 is good, no problem, 0. So that actually need to be factored. So I'm going to factor 8x. I'll have x minus 6. That means that's greater than or equal to 0. All right? I can make this greater than or equal to 0. So that means x cannot equal to 0. Oh, my apologies. X can equal to 0, no problem here. 0 minus 0, that's okay. X actually cannot equal to positive 6. Okay. It's greater than or equal to 6. Okay. And so, and x is great also less than or equal. My apology for this little confusion, because you get two values here. You have a value for x to be 0, and the value for x to be equal to 6. So the higher number gets the sign, because you can put 0 here to make it 0, and you can put x is 6 to make it 0. So you get a 0. Let me write this. My apology for this little confusion. You can have x is 0, we make it 0. X is 6, we make it 0. The higher number get the same sign. X is greater than 0, and x is less than or actually equal to 0. Less than, the smaller number gets the less than, the bigger number gets a greater than. All right? So number line 0, 6, greater than, less than. So that will be equal to negative infinity to 0, 6 to infinity, bracket and 6 and 0, because it can't be, no problem. Union this. Now remember for this example, I did it specifically to show you that when you have two x's here, what value for x to make the thing is 0? X is 6 will give you 0. X is 0 will give you 0. So I get two values here, 0 and 6. The greater number get the bigger number get the greater than, the less number or smaller number or the negative numbers gets less than. So what I just recorded now is how you find the domain algebraically, and we did a couple of examples. I hope you guys understood what I just explained you. And if you have any question, please don't hesitate to write it in a comment. Thank you for watching. Please don't forget to like, share, and subscribe. You guys have a great day. Bye-bye.